Today we are treating velocity and acceleration vectors, then plus relative velocity. So first of all, when I'm talking about velocity vector, we know that if you check very well, you will notice that anything vector, in as much as they give you many definitions, but once you notice, it's not just about magnitude and direction. Notice that the direction has specific targets. It's either it's going in the y-axis or it's going in the x-axis, and when it's not going in these two axes, maybe it's going in this way. We try to say, how do we take this to y-axis and how do we take this to x-axis, which is now what we call resolution of vectors. We try to start doing, how do we resolve it to go to y and x axis. So whenever I'm talking about velocity and acceleration vector, it's simply talking about checking velocity at y-axis and checking velocity at x-axis, taking note of the velocity at x-axis and the y-axis. That is what velocity vector is all about. Or you say it's the displacement of an object in the y and x components. The same thing with acceleration. You can say that acceleration is the change in velocity of objects in the x and y axis. And you know that once you have anything that has to do with vector x and y axis, at the end of the day you use Pythagoras to get the sum. So it simply means getting the velocity that happens at x axis, getting the velocity that happened at y axis, then using Pythagoras get the resultant. So that I now have, and this resultant now is going to be the total velocity, which is v now. So I will now have vi square plus v j square. So that's the first thing you need to note about velocity and acceleration vectors. Then for relative velocity simply talks about the velocity of an object due to the velocity of another object. Relative velocity talks about velocity of an object due to the velocity of another object. Are you seeing it? So if I have somebody running running inside a train, I have somebody running somebody running inside a train. You can see it. So the train is moving, this person is moving. So you see that both of them are moving in the same axis. They are moving horizontally, both of them. So we say that since they are moving horizontally, there is no vertical motion here. So we say that the relative velocity, the total motion here, is simply going to be in the x-axis. So we say that this velocity will simply be the velocity of this person moving plus the velocity of the train. That is what the relative velocity will be. But a situation, that is what the velocity will be. But a situation whereby, let's say you have a river, and people are using boats to cross this river. This is the boat, then this is the boat, then this is the river, this is the river, then this is boat. You see very well that this boat is moving this way and this one is moving this way. So we can say that we have y and x component depending on what the question states. If they say that the boat is the river is flowing east and the boat is going north, this example gives us that this is y and x component. So at the end of the day, I will get the velocity for the y. So for the y axis, yes, I get the velocity for the let me correct this. What I did here, this is supposed to be vj and vi. X is always I, x is always the I, then y is j. So notice that everything vector has to do with the summary is taking it to x axis. So this now will become the velocity on the y-axis. This on the j-axis. This will become the velocity on the y-axis. So now, anytime we have something of x and y component, to sum it up, the relative velocity now here will simply be velocity at y-axis square plus velocity at j-axis square. So that is a summary of what you need to know about velocity vector, acceleration vector, relative velocity. So now let's look at this one that you normally encounter in physics, instantaneous velocity. Anytime you hear instantaneous, it simply means at a particular time. Instantaneous velocity is simply the displacement of an object over a given time at a particular time. See what I mean? While average velocity is the velocity of an object or the displacement of an object over a period of time. So see what I mean? Let's say this is the velocity that happened from x0 to x10. Guys, this is the displacement. You know, the displacement over time. Then let's say it happened at time t2 to t1. This whole thing inside here, let's say as this thing is moving from 0 to the point where it happened at point 1, you know that this is x in 10. So at that point of x1 is instantaneous velocity. At the point of x2 is another instantaneous velocity when you are comparing it with time. So at the point of x2, x1, x3, x4, x5, x6, x7, x8, x9, x10. So all these different positions that happened before you got to the actual displacement you are looking at is what we are calling instantaneous velocity. When you do this now, it simply means that you now have from t1, t2, t3 to t4, t5, blah blah blah, to t10, to when it happened. So instantaneous velocity is simply velocity at an instant, or you say particular time. For each time, that's what instantaneous velocity means. So it's the displacement. You know that velocity is displacement over time. So it's the displacement, the change in displacement over time. Change in displacement. So it's no longer going to be just change in displacement over time. It's going to be the instant change, or the displacement at a particular time, at a particular instant, at a particular time, or at an instant in time. So you take note of each one consecutively. That is why we normally take it that anytime we're talking about instantaneous velocity, we compare what is happening at x-axis and what is happening at y-axis. We say that it is gotten from the slope of velocity, or as you say, it is the slope as x tends to 0. So we can simply say that at any instant in time, what happened here and what happened here and what happened here, by the time you get the slope, by the time you get the slope, let's say I now make a triangle on this. So by the time I get the slope, get what happened at each instant stated at each instant. So by the time I do this using our principle for slope, where I now come and do y2 minus y1 all over x2 minus x1. So whatever I get becomes my instantaneous velocity. Alright, now let's check for average velocity. Average velocity talks about velocity of an object or of a particular or displacement with time over a period of time. So it can be from this point to this point, or from this point to this point. So you see that it takes time, or taking note of everything that happened here. All right, so with that said, we can look at a question. Let's use questions to make this understandable. Sometimes when you're speaking grammar, if someone is not used to that kind of line of understanding, it will look as if it's taking long to enter. But let's use questions. Mathematics is the language of physics or science. So let's use interpretations, mathematical interpretation relating it to physicality. They said a vehicle has, okay, look at how I define relative velocity here. I said relative velocity is defined as the velocity of an object with respect to another. It is the velocity of an object due to the velocity of another object. So I said a vehicle has initial coordinates x1, y1. So this is the vehicle. It has initial coordinates x and y. So on the x it has 10 meter, on the y it has 20 meter. So it has the coordinates, that is at initial, it has initial coordinates, so at given time. So let's say this is time, initial time at beginning, t1 is 0. That is when it started. Yes. Now it says 2 minutes later, that is after 2 minutes. After 2 minutes, the coordinates x and y is now 20. This one is now 12 meter, and this one is now 21 meter. That means t2 equals to 2 minutes. We don't need to convert, but you can convert if you choose to. Okay, so watch, and we know that a minute is 60 seconds, shebi, while 1 hour is 3, that is 1 hour is 60 seconds times 60 minutes, which is 3600 seconds. So if I want to convert this to minutes now, I'll simply say 2 times 60. Okay, so what this thing means is that anytime I'm doing this type of question, I need to take notes. So what I will do here is to simply say this is the velocity, the initial velocity u. So yes, sorry, it didn't even talk about velocity. What it talked about is the initial coordinates. So, and this is meter, this is meter, so it's not u but s, distance. And I told you distance and displacement are the same thing, provided they did not talk about change. So position, so this is initial displacement, final displacement on the y-axis, on the x-axis, so sx1, while on the y-axis this is the initial displacement, sy1 and sy2. So what we just need to do here is to simply say, to get the instantaneous, or you say the position vector. Position vector, remember position vector talks about the sum of everything that happened. Let's say if I have x1 and x2, position vector talks about summing it up, everything that happened on x-axis, then everything that happened on y-axis. That's position vector for you, taking note of it. But once you talk about the velocity, velocity now, you start doing change in the position vectors, which is going to be x2 minus x1, and here position vector will be equals to y2 minus y1. So you need to know this. So since I have the position vectors, assuming I'm doing position vector, I'll simply say what I have here is simply 10 plus 12, 22 meter. On the y-axis, 21 plus 20, 41 meter. But here I'm talking about, they told me what are the components I have shown you the components. Magnitude. So by magnitude, they mean the resultant. So whenever I'm talking about magnitude, I'm supposed to look at the velocity and direction of its average velocity for these 2 minutes. And direction for its average velocity for these 2 minutes. So you need to know that whenever they are telling you about the magnitude of a component, it's talking about Pythagoras. Pythagoras theorem, that is x and y axis, the Pythagoras. So this is going to simply be the sentence as saying subtract x1 subtract x1 from x2. So I will do 12 minus 10, that is for the change in the sx. So I will have, this will now give me 12 minus 10. Shebi? Yes. So it's going to be the sentence as saying 2 meter. 2 meter. That is the change in the displacement. Now remember that velocity is the sentence as saying velocity is the sentence as saying, like I've highlighted, the sentence as saying change in s all over change in t. So this is going to be the sentence as saying 2m. Notice that the change in time is t2 minus t1, which is so all over 2, which will give me 1 meter per second. And notice that here we are not treating seconds. What we are doing is in minutes. That's what we are given. So I want to use the minutes. If you want to convert your own, you can convert your own. So I now have for Vx. Now for Vy, I don't like putting average or whatever. I will have change in Sy is going to be equals to 21 minus 20. 21 minus 20, which is equals to 1. Is equals to 1. That is, this is y, this is y, y2, y1. So it's going to be changing sy all over change in time. And this is going to be the sentence as saying 1 all over 2, which gives me 0.5 meter per minute. And see, now that I've gotten this, to get the magnitude, like they said, to get the magnitude, I'll simply now do take everything for x, all the velocity for x now to x, which is 1 minute, 1 meter per minute. That is Vx. Then for y is 0.5 meter per minute, which is Vy. So the resultant, that is the total V. That is Vy plus Vx. That's the resultant, or you call it magnitude. That is what we want to get. And to get this is a right angle. We'll simply do V is equals to V square equals to Vy square plus Vx square. V is equals to magnitude of Vy square plus Vx square. And notice that this will give me the sentence as saying V is equals to square root of 1.25. Do your own. And when you take the square root, you get 1.12 meter per minutes. So remember the question also asked me to show direction of its average velocity for this 2 minute interval. And direction, I told you in our last class that anytime we solve for resultants using Pythagoras, always use tan theta equals to sine theta over cos theta. But notice that we are not using this now because there is no trigonometry given to us. So the value of sine theta is y, value of cos theta is x, and right here y is 0.5, x is 1. Okay, let me just write 1. No need putting the units. So you see that means that theta will simply, anything divided by 1 is that thing. So theta will simply be tan inverse of 0.5. And theta will be equals to 26.6 degrees. This is our theta, which means that the direction is in the first quadrant. So it's in the first quadrant. Remember I told you the first quadrant is here, 90. This side 180, 270, 360. And we normally start from this side, going around. So let's move to the second question. Okay, they're asking us what is average acceleration, instantaneous acceleration, relative acceleration. We've talked about that. So I said that average acceleration, I can say that it is the ratio of change in the instantaneous velocity to time interval. So that is what average acceleration is. So I said average acceleration is the ratio of change in the instantaneous velocity with given time, or you say over a period of time. So see what I mean. What I mean by average acceleration. What I mean by average acceleration is simply, if I have change in v of y, get it. Get it for me. Anything that happened at v of y, get it. And everything that happened at v of x, get it. All the changes, get it. So if I have maybe displacement and so at this one, that is the velocity at maybe y axis, happened up, happened down, whatever happened, get it. Then plus whatever happened at x, the velocity at x, and whatever happened at y. Sorry, this is t. This is t. What are you doing? So remember that we normally compare, we normally say acceleration naturally is change in velocity over time. So when you're talking about average acceleration, it's the same thing. But this time around, you are simply talking about the acceleration that happened over a period of time. Over a period of time. And that acceleration that happened over a period of time, you just need to check what happened at the x-axis over a period of time and what happened at the y-axis over a period of time. Then when you finish, you now know that anything that has to do with x and y-axis, the resultant is something that you will use. It's something that you will use this our method, which is a squared. That is a squared totally is going to be the same thing as saying what I have on the v on the ay axis plus what I have on the ax axis. That is when you must have gotten this. You know that everything you have here will give you acceleration at ay, and everything you have here will give you acceleration at x. So square square. So that's what you need to know about that. So let's try look at the next one. Instantaneous acceleration. I've told you instantaneous acceleration or anything instantaneous has to do with at an instant in time. So if I go to x at particular points in x-axis, what is happening there? That is what you need to take note of. So I can say that at a particular time in x or in the y-axis, I notice that, see what I mean, 0, 1, 2. What I have here, if this is the acceleration I'm talking about, and you know acceleration is gotten from velocity time graph. So what I have from this point to this point is instantaneous velocity, instantaneous velocity. Then what I have here is instantaneous velocity. So for each point here, let's say I come and do 1 minus 0 all over. What time did it happen? Let's say it happened at maybe 0.2 here. This is the time here. I will say 2 minus 0. So this is going to give me 1 over 2. This is instantaneous acceleration. Remember that this is v x or vy. Then I got the time for it to happen. That is change in y and change in t. So notice that right here, as I'm doing this, when you are looking at y, you don't look at y and x at the same time. So I said, let there be a velocity that's happened along the y-axis, and at a given time, I bring it out. What I've noted here is instantaneous acceleration at y-axis. Now let's say there is a velocity that happened along the x-axis, and you know that whenever you are comparing velocity, we normally look at it on this axis, that is in y, and time this way. But let's say that when we are doing vector, we make provision of that something could happen at x-axis. If you remember, let's say there is a velocity that happened at x-axis, let's say from this point 0 to this point 2, and let's say it happened at a given time. We must be given time. Don't come and say because it's why is it coming this way. So let's say we are given time 2. So when we check it, whatever happened, we'll compare it this way. That's instantaneous velocity. So but you see that trying to explain this way makes the whole thing complicate what we do when we are plotting graph for velocity time graph, which gives us acceleration. So you simply need to know that the summary of what I'm trying to give you there is that when you are treating vector, you compare y and x-axis, the different velocities that happen there. And when you relate these different velocities at y-axis and that of x-axis, so vy then plus vx, and you are able to show the time. Remember that this is change in this, change in this, and you're able to relate it with change in time. Whatever you have at that point, after everything, so far as it's change in velocity you are treating, once you're able to compare what happened at y, compare what happened at x, the summation, the summation of what you have, the summation of what you have happening here and what you have happening here gives you what we call instantaneous acceleration. That's what you need to know. While the average acceleration is simply after you've gotten this and you've gotten this. Notice that this is just one instantaneous. There can be many of it. There can be more of this. There can be more of this. That is, this is for a particular time. There can be more of this at a particular time. When you're able to take note of everything that happened, that is average acceleration. All right. Let's look at this question. They said relative velocity. I've told you that relative velocity is defined as the velocity of an object with respect to another. So they said a stream flows west to east. So whenever I'm treating this kind of question, remember I told you in class, rush and draw your coordinates so that nobody will confuse you. They can tell you a man moves north of east. This is north. this is east. If I don't know this thing, I will start drawing something like this, which will confuse me. But if they say a man moves north of east, the minute I see this at an angle 35, the minute I see this, I will know that whatever is moving, the angle will be this way, because it's from north coming to east. The angle will be here. But if you don't put this thing and you just know it, you might start doing north of east is going this way. This is east. You come and do this thing. This is wrong. You see it? So always put your coordinates. So the minute I hear the question, they said a stream flows west to east. I just come and draw my coordinates so that nobody will confuse me. Now this is west, this is east, north, south. So stream flows west to east, west to east, this way. But notice that if it's moving this way, simply going east directly. If it's moving this way, it's going west. So I need to show an angle to indicate the west to east. So it's from here, it will cross and come to the east. Are you seeing it? So they now said, so it can continue going this way. They now said that, okay, a stream flows west to east with a speed of 3 meters per second. So it's going this way. Remember that the relationship between west and east. So it's more like, see, I have east, I have west. It's going this way. Towards the east. From west, it's going towards the east. And this relationship is 3 meters per second. Then they now said, a boy swims north. A boy swims north. A boy swims north. Let's say this is this boy swimming. It will come and meet the river flowing towards the east, one place. See that it has formed a triangle. Across the river with a speed of 4 meters per second. Boy is swimming north. You can continue going, no problem. River flowing, no problem. So, but what we are checking is now, it has met this somewhere. Okay. Across the river with a speed of 4 meters relative to the water. What is the velocity of the boy relative to the shore? What is the velocity of the boy? So they are asking us, what is the velocity of this boy relative to this shore? So in order to find the velocity of this boy, we simply need to find, see, we have this. So in order to find the velocity of the boy, we need to find the resultant velocity. Because he's moving with this 4 meters per second. This one is going 3 meters per second. So the velocity of the boy is 4 meters per second. The water is moving 3 meters per second. So to find the velocity of the boy relative to the shore, that's what they asked us, relative to the shore, we simply need to take note of the boy relationship with the moving water, which is simply getting the resultant. So I'll simply say velocity of the boy relative to the shore is equals to, this is Pythagoras I'm doing. Anytime I want to find something here, is equals to velocity of the shore square plus velocity of the boy square, which is essentially as saying 3 raised to power 2 plus 4 raised to power 2, which is equals to square root of 9 plus 16. 9 plus 16 should give me, should carry 4, put a 25. Square root of 25 is 5 meters per second. So that is the velocity of the boy relative to the shore. Very simple. Down. Did they ask us to find any other thing? Assuming they say find the angle. You know how to find angle. Once you use Pythagoras to find resultant, you must use tan theta. Okay. Yes. Yes, they said, what is the velocity of the boy to the shore? Okay, so we've gotten it. Yes, that is it. So that is the velocity of the ball to the shore. But if they said find the angle, or they said find the direction of the ball, yeah, the direction, I can now come and do, remember I told you tan theta equals to y over x. I'm not supposed to be solving this one. You're supposed to have grown to this one now. So, and y here is 4, x is 3, 4 over 3. So you do theta is equals to tan inverse of 4 over 3. Whatever answer you get is your answer. Okay. They say summarize the difference between cosine angle and the sine angle of two vectors. So whenever they tell you find the cosine angle and sine angle of two vectors, know that what they are trying to tell you is to find the angle for dot product and that of cross product, and it's simply given by a dot b is equals to a magnitude b cos theta. Why? To find, notice that this will now be the same thing as saying cos theta is equals to a dot b all over a magnitude b magnitude. So theta is equals to cos inverse of a dot b over a magnitude b magnitude. Notice that here I did not do anything like magnitude. Nothing like magnitude, is just a dot b. Yes. But for cross product, I'll first go and find a cross b. Get it. Get what a cross b is. Now to get the angle between the cross product, I will have a cross b magnitude is equals to a magnitude b magnitude sine theta. Notice that there's magnitude here, and you know how to find magnitude. Magnitude of a cross b is the same thing as saying square root of everything I have in the a and yes, on the I-axis. Okay, a cross b, let's say I use I now. Everything I have on the I square plus everything I have on the j square plus everything I have on the z square. So when I do it, that's the magnitude of this. And remember that this one normally comes with I and j remaining. So you just remove the I. At the end of the day, this is the same thing as saying 1 times anything you have there plus 1 times anything you have there plus 1 times anything you have there. This is z. So times, let's say, AB value, AB value, AB value. The values. So now that I know this, to get my theta, I'll first of all have sine theta is equals to magnitude A cross B all over magnitude A, magnitude B. So sine theta will be equals to sine inverse of A cross B all over A magnitude B magnitude. Sine inverse of everything here. All right.